This video is going to be about working on your labs. We're going to start off just looking at a surface weather map. That's what you're going to see the first week or so of your lab. So with that in mind, surface weather maps are basically high and low pressure. So these are pressure. The contours are isobars right here, you'll see. So you have high pressure here over Kentucky, low pressure that's north of Maine, northeast of Maine, another low over Hudson Bay up here, very weak low over the southwestern part of Texas, down along the Gulf Coast here. So these are different areas of pressure change. High pressure just means the pressure is higher, low pressure means the pressure is lower. Typically, high pressure brings good weather. Typically, low pressure brings bad weather. You also have fronts. We've talked about the idea that we talked about this week is air masses. Air masses are large masses of air covering large areas, really, that all have similar quality. So I'm looking at this map. I see this high pressure here, and I have a cold front over here. Temperatures are generally in the 20s and 30s with this high pressure system. Dew points are down around 10 to 15 degrees. So broadly, it's a cold, dry air mass. So that is a typical high pressure. If I was to go off out here, there's another high. Can't see it out here yet, out ahead of this cold front. That high has warm air with it. It has temperatures in the 60s and 70s, dew points in the 50s and 60s. It formed over the more tropical ocean, so it's warmer. So these fronts, cold front means cold air is advancing. Warm front means warm air is advancing. So that is the first step. So when you see a cold front and the direction of these barbs, triangles, indicates the direction of motion. The semicircles on a warm front indicate direction of motion. This warm front's moving north. This cold front's moving to the east. So now you have looked and have a little feel for a weather map. So now we're going to look in more detail. The idea here is to look at a station symbol. How do we plot a weather map in the first place? All these station symbols, and we're talking about a symbol like this or this, are plotted from observations. The observations may be by ASOS, they may be by AWOS, they may be various, even people-generated observations. But as many of us as we can get around the United States, we're going to plot. Around the world, for that matter. We want to know what the weather is in the whole world, really. So, with that, I'm out in Oklahoma generally just because it was kind of interesting and had some snow. So let's take a station right here, which is actually Tulsa, Oklahoma. Upper left, temperature is 30 degrees. The temperatures are always plotted to the upper left on these diagrams. So please remember that. That is your temperature. So if I go over here to some other place, 33 degrees is the temperature. 34 degrees. These are all in the upper left-hand corner of that station plot. The lower left-hand corner is the dew point. It's a measure of moisture. The lower the number, the drier the air. So here's 25-degree dew points. Here's 22-degree dew point, or 17. Down here, there's 32-degree dew point. So now you've got two of the numbers here that you need to make a complete plot. So if I told you to walk outside, tell me how cold it is, how moist it is, those are two things you would have. Look at the center of the circle here. You notice it's covered in, completely covered in. That is clouds. So if skies are cloudy, the circle is going to be totally covered. If skies are clear, like over here, there's nothing around that. So again, the symbol is in the middle, is like you were looking up into the sky above you. And how many clouds do you see? You see a whole sky totally covered, or just a little bit of cloud cover. So now we've gone through two parts of it. Another part is pressure. We got to plot these lines somehow, right? So right here is a line that actually is 1024 millibars. All pressure along that line is 1024. You'll notice it goes right through here, and actually right a little bit off of that, and that pressure is 1023.4. Here's a 1023.5. So why did I make those tens put in front? We take all pressures to a tenth. So in other words, instead of 1023 and nothing, we take it to 1023.4. So if you see a weather map, you're always going to be adding something, a number to the front of those three digits. Now, I'll tell you this, it's simple relatively for your course. If you have anything above 500, typically, it's probably going to be a 9 in front of it. So I say I had an 899. That would be 989.9 would be the pressure. So that would be adding a 9 in the front. So please remember that. If you have confusion with that, let me know. We'll talk about it some more. Now, winds. Look at your circle here. If you were standing in that circle and you wanted to look in the direction of where this barb is, what direction would that be from you? It would be to the south-southeast. So what that is saying is that is where the wind is coming from will hit you in the face if you're looking in that direction. So it's a south-southeast wind. The barb indicates where the wind is coming from. Let's take it over here. You would be coming in from the north here. So instead of facing to the south, if you face to the north, you'd have the wind in your face. You face to the south, you'd have the wind at your back. So, and now we want to know the strength of the wind. Wind is two components, a direction and a speed. So the speed is right here. These barbs, long barbs, indicate 10 knots. So here's 10, 20, 30 knots. Here's 30 knots. Here's 25 knots. You have to see the smaller barb here. So it's a real simple way to know what the wind speed is. So over here, it's 10 knots out of the southeast. Over here, 5 knots out of the east-northeast. So again, that gets you your direction and wind speed. So when I ask you for the wind, you're going to give me a direction and a speed. All right. So now you've looked at everything but this little stars here. What are these? All right. Most of us are very interested if there's precipitation occurring. So that is what this is, precipitation. 2, in this case, stars, is snow. A star indicates snow, and it's light snow if it's 2. Notice over here there's 4 stars. That's heavy snow. So the snow is probably down pretty good in that area. Here's 3 stars. That's moderate snow. All right, so let's go down here where there's some dots. There's 2 dots. 2 dots is light rain. Rain is a dot. So here you have 2 dots with light rain. Here you have a little squiggly around one of the dots here. That means it's freezing rain. Notice the temperature is 32. So we have freezing rain here. So it is rain that is freezing on the ground when it touches the surface. Not fun to drive in, as we all know. So now you have looked at a station symbol. So we've gone from a large weather map to very detailed in the small scale on the weather map. Finally, I just wanted you to see a plot. We call them meteograms. They're going to show up once in a while in your labs. All we have done is one of these stations, in this case it was Mansfield, Ohio. Every hour we have the temperature, dew point, and relative humidity plotted. So if I go along here, I can see what the temperature was, what the relative humidity was at any given hour. So I can watch the temperature stay up, rise up a little bit, come down, and really go down here, right? Drops right off there pretty nicely. So you can see the temperatures, relative humidity, or dew point here with this plot. You can plot pressure as well. You can even plot winds. So these are meteograms. They're going to show up periodically in your labs. Oh, what we've covered is basically looking at a surface weather map, the meteograms, individual station plots on a weather map. So that should give you a good handle on the first couple of weeks of the course. We will be moving into the upper air shortly after that. You're going to look at Stuvie diagrams. All they are is a vertical plot of temperature, dew point, and wind in the vertical instead of in the horizontal like you're looking at. So weather is a vertical, three-dimensional system. So hope you get this. Let me know if you have any questions on this, because 30% of your grade is on the lab. So these are something you need to understand.